morning. This afternoon, I'm getting that shot. Looking a little sludgy. Yep, this afternoon I become hopefully superhuman. Right. Thank you. One of the other faculty tipped me off to so there's a subreddit for coronavirus vaccine locations in Michigan. I didn't know about it until last night, but apparently people are aggregating locations where you can find the vaccine. It's like coronavirus Michigan, I think is the sub. Okay. Let's get going. So, well, really one thing. Um, yeah, I'll drop an announcement later if anything's going to be different for Friday. Not sure yet. But I put your next homework up, so you have until the 2nd, which is a week and a half. I figure that's plenty of time to get it done. But it is HW4. Why? Okay, Blackboard, you're just the worst. These are supposed to be at the bottom. Let's move them back to the bottom and see if it sticks this time. Please stay here. Don't move. Search for HW4 if you can't find it, or maybe I need to add links to these because this is really annoying for you to have an unsorted list of assignments. My anal retentive nature really hates the fact that Blackboard can't handle this. But HW4 is up, and basically it's 2 parts, so they're both due the same day. And again, April 2nd by midnight, per usual. So you have a few questions to answer for individual efforts, just to make sure you're keeping up with the material. You can get a feeling for what kinds of questions I would ask on, say, a final exam. And yeah, answer this part individually. 3 questions shouldn't be that hard, but put some effort into your actual answers as usual. One sentence answer is probably not going to be the way to go, and a full page of answers is probably too much. But yeah, if you have any questions, please feel free to let me know. The group work is the fun part where I want you to come up with a list of tasks remaining for your project. And these should be high level, right? It shouldn't be your team's days planned down to the day and hour. It should be more the high level things we need to get done. And I want the name of the task, a short description of the task, approximately how much time that task will take to complete, and the person or people in charge of making sure that task gets done. Okay, so everything we talked about last time with planning out your projects, I would like you to do here. This will help you get a feel for what is left on your term projects and what you feel that you have to do. And if you feel like you have way too much going on, this is where we start talking about scoping, right? Do you have like 2 tasks left because it's not enough? Then maybe add on a few more. If you have tasks scoped out to the middle of summer, you probably have way too much going on. So this gives you a feel for exactly what has to be, left to be done. And with that, list out what you've done already and what you have yet to do. So this should be a markdown document, and then either create a Gantt chart, a burn down, or a burn up chart and commit it to your docs directory as well. And this should be a PDF. Now, it is up to you which chart you pick. I don't personally care. A Gantt chart's probably going to be easiest based on how we've structured our projects currently. But if you want to go the agile route, that is also fine as well. Um, Typically with burn down and burn up, you would use like user stories as your metrics, but we could count these tasks for that effectively. And if you don't know how to make one, which is perfectly fine, I haven't really given you the links for it yet, I've just shown you the examples. These slides from today are going to cover this. Basically, everything from today is going to be this homework assignment. That's why I kind of held off on putting it up. But at the very end are a list of, let's see, so a list of links for you to get up and running. I don't have MS Project, so I don't have the ability to create Gantt charts fancily with Microsoft. I'm not expecting you to either. Lucid Charts is an option, but you have to sign up for their service, and it's a paid service at some point. They have some very cute snack videos. But if you want to do a Gantt chart in Google Sheets, here's how to do it. You can use draw.io, which has a template for Gantt charts. Here is a example for creating burn down and burn up in Excel. Basically, you just do formulas. You list out the appropriate fields, and then the formula would create the chart for you. And if you're going to use a Gantt chart, here's a list of tools that you can use that are open source as well. There are web-based tools out there. Some of them you have to sign up for, some of them you don't. My only suggestion would be don't pay for anything. It's not worth it for this one assignment, unless you've already signed up for, say, Lucid Charts. But yeah, don't pay for anything in here. But we will hopefully get to that point today. So effectively, just to summarize, if you missed the beginning, homework due in a week and a half. Main focus is going to be group effort on planning out the rest of your project. Sound good? Let's see, I don't remember any of my emote bindings, and I don't have the link, so we'll just go with Velociraptor. So let's continue on. And what we're going to be talking about today is actually estimating the costs of your project with a few different methods. I don't know that we'll get through all of this today. It's a lot of formulas, a lot of material. I'm not going to expect you to have to calculate out these models. So just kind of keep that in mind as we go through this. Um, if you want to go the project management route, you probably will go down one of these paths, but we don't have all the information that we would need, in a a simple class-based environment for a big empirical model evaluation. At least I don't feel like we do. We could do toy problems, but that's not going to be super helpful for you. So what are we doing here today? We're going to look at different methods for estimating cost. We talked about this at a high level last time. Now let's actually figure out how we can do this. So how do we figure out costs? Well, one way is to bring in an expert. All right, so we are starting out a brand new project. None of us are actually experts in this domain. Maybe we go bring in a consultant, or we talk to somebody who has done a project like we are building right now. Ask them to, here's all of our metrics, here is our, kind of list of tasks that we have to do, here's all the resources we think we're going to need. How much do you think this is going to cost us as a company to build? Factoring in employees, factoring in licensing, all this. Basically, we're going to bring in experts and they're going to give their opinion. These experts will probably have empirical tools at their disposal, meaning they're going to have models and pre-baked kind of algorithms or spreadsheets set up where you plug and play a bunch of values and it spits out an approximate cost. Typically, this is going to be an iterative process too. So, maybe if we have multiple experts discussing this, they'll start very broadly and they'll start, kind of narrowing down, arrive at your estimated cost at the end of it. And this is going to include, the people, the resources, so on and so forth. But the key here is expert judgment. Now, how do they do this? Well, they're going to need a work breakdown structure, which is going to kind of follow this notion of tasks that we've been talking about. And the acronym here is WBS. This is one that I just pulled off of Wikipedia as an example. I think it's kind of a nice high-level overview. But here we have an aircraft system that we are building. So let's say that we are, GE Aviation, or we are Grumman or Boeing or somebody, right? Here is our intended deliverable, just a aircraft system. What do we need? Well, we need the air vehicle, we need training, we need data, we need support equipment. So basically all of these kind of subsystems that would go into the greater system. All right, well, what is the work that has to be done for all of these subsystems? Well, if you're actually building the thing, well, it needs an airframe, it needs propulsion. We need software for various systems that are on it. It's going to need automatic control. It's going to need weapons if this is a jet fighter, for the Air Force or the Army or something like that. You can kind of see how this one massive project can be broken down into separate project teams and projects, right? Just building an airframe, it's going to require a lot of mechanical engineering knowledge and a lot of fabrication. So we're going to need to spec that out. And we'll go through these each individually. A project can be a very massive undertaking, and figuring out the total cost of this is not something that you can bang out in a day, with a, best guess. There's a lot of analysis that would have to go into this. Training, even. Training can be a subsystem. Training your pilots, training your support staff, training your engineers on every single piece of this equipment. It's going to cost money to go out and train people. Right? Either you hire consultants or not consultants, contractors to come in and do the training. Maybe they're good at public speaking, good at getting people to understand things. Or you train your internal staff to go out and be able to talk to people about this, right? So if you kind of look at a figure like this, obviously a tree-based structure, you could take this and apply a work breakdown structure to really any project. Your term projects could easily fit into this, right? Your greater system is a, let's see, what's one of your projects? The dancing stick figure, right? So the GUI dancer team. I should mention too, so I went through all your evaluations. I will put those up pretty soon for everybody's teams. It is a big, horrible mess right now because I just copy and pasted everybody's responses. So what I'll probably do is I'm just going to dump it into a set of documents without too much formatting, because the important part's the content, right? Not making it look pretty. I'm pretty sure I could spend a solid 2 or 3 days with making it look nice. But take the GUI Dancer team, right? So GUI Dancer is the high level system. What is our next level going to be? Well, you need to have drawing libraries. You need to have, I think we're at the point where you guys are talking about physics interactions, right? Interactions with the user, joint movement, any kind of data storage that you need. What are the libraries that you need to draw things? I think I said that already. Handling multiple operating systems if you're going that route. If you're building it in, say, Unity, you can export to Android, you can export to web, export to Windows, export to Linux, export to Mac. Basically, we can break down projects this way. And by doing this, you can get a feel for how much everything is going to cost, and then we sum everything up with probably a little bit of padding for emergency, and then you get an overall project estimate. So, point number one, bring in an expert. They're going to know how to do that calculation. Okay. Estimation number two, we can do it by analogy. So what does this mean? Well, if you're working at a larger company, the odds that this is the first time this project has ever been completed are pretty small, right? So you go to work in automotive, um, and we can take my past experience working on a camera, or you're working on a radar or a LiDAR, any of these subsystems used to provide information to the vehicle controller. It's probably not the first time that we have done this project, because we probably have done it for Ford, and then we did it for Chrysler, and then we did it for GM, then we did it for Fiat or Toyota or any of them. It's probably going to cost about the same. Each manufacturer that is contracting us may have different requirements, and that may play with the overall cost, but it's probably going to be about the same. So we can analyze what the current project workload is, what its specifications are. How similar is it to the last project we did? If it's pretty close, then the odds that the costs are pretty good are pretty high, right? And if it's the first time that you have done this, there's nothing stopping you from reaching out to other companies who you are on friendly terms with and discussing costs, right? It's not a completely type of cutthroat thing where everybody hides all their information. Sometimes you can have good working relationships with other companies and you can discuss project cost estimation. This is usually at a higher level than the engineering staff, though. So we can estimate. One thing to consider, so we talked about some of our general laws in the past, right? We talked about Murphy's Law and we talked about Parkinson's Law is another one, but this is something to consider. As we spec out our projects, there is this law known as Parkinson's Law, where if you have a set time of work to be completed, what you're going to do automatically fills up that time. So if I tell you, okay, we have a term project due at the end of the semester, we're starting on day one, the amount of work that you have to do is just going to fill that time slot regardless, right? If you start out with the simplest of simple, let's do a terminal-based choose your own adventure game, where the only thing we're doing is pick option 1, 2, or 3. Okay, that's something you could probably get done in a few days. And the hardest part's going to be filling in story entries, right? And if I tell you, well, you have a whole semester to work on this, okay, day one, we're going to work on the interface. Day two, we're going to start figuring out a grand story for the person to go on. Week three, we realize we're kind of bored with this project, so let's make it interesting. This is now a sprawling choose your own adventure set in Skyrim or any of the D&D settings, and now all of a sudden we have a semester's worth of work. Kind of the thing is that just be aware that if you set an unreasonable time, you're going to have work to be done in that time. It's one of those weird, kind of laws that ends up happening. So if you're following this notion, the cost of a project is basically going to be determined by the amount of time that you have and the amount of people that you have to work on this thing. So this is not really an objective assessment of your actual project efforts, and it's an assessment of the time and the people and the resources there. So if we say the project has 12 months, so we have a year to do this project, and I look around my project team, everybody is busy except for 5 people. Well, I have 60 person months worth of effort, 12 times 5. Very simplistic viewpoint on this, but that is one way that we can estimate costs. And if 5 people are not enough, then we're going to quickly see that this estimate is bad, right? And if 5 people are too much, then we're way overconfident here. And this is a metric that we'll be using as well, the person month. So this is let me pull this up. This is one metric for kind of analyzing effort as well. So cost isn't just money, it is in person days or person hours or person months. That's basically just how much time a person will spend on a typical working week, a 40-hour working week to a project, right? Hopefully that makes sense. And if you go into industry, you'll start hearing person months instead of just months. It'll be a slightly different metric. All right, so estimate based on resources. We can also estimate based on how much the customer is willing to pay. So that's always a fun one. If I come to your project teams and I say, I have $1 million to play with, I want you to make me the next app that's going to sell 5 billion units at 99 cents a piece. And you say, great, it's going to cost you $1 million. um, Basically, we could go the route that we are willing to pay, or we are willing to estimate that our project cost is going to be whatever you have to spend on the project. And we're not estimating based on functionality. We're not estimating based on effort. It's literally purely money. Is this a good idea? So, question to you all. Is estimation by cost a good idea or not? And why? Any thoughts here? Or have we all zoned out at this point? Which is fair. No. No, because a product may be subpar and there be an unforeseen cost. That is true. That's true. But we can take this the other route too. So some things just aren't possible. Absolutely. So keep in mind when we kind of go this route, right? We're not trying to be sneaky about this, or we're not trying to be, you know, too altruistic coming from the other side of things. If a customer says this is the amount we are willing to spend, that may be acceptable. The difference though is that what we do after we agree upon that. So let's say that I have that $1 million and it's actually going to cost way more to get what they want. Maybe we scope it a bit. Wouldn't this route guarantee the customer keeps their budget? Yes, that's the other point too. We can't go over budget because there is no more available than what they are willing to spend. Yes. So if we have a project that the customer has in mind and they're willing to spend a certain amount, if we go outside of that budget, then there's obviously a big problem. But if we are at the point of cost estimation, we can try to scope things. So we go back to this, the work breakdown. If we look at this and we can very easily see, there's no way this is $1 million, this is in the billions for this amount of effort. Well, maybe we don't build the whole aircraft system. Maybe we just, build the guidance control software and they have to figure out what they want to backfill the rest of this, right? Maybe they can get grant funding or. But it's not always a bad thing. It's not always a good thing. It just kind of, again, it kind of depends. So we have another way to look at it too. They're schedule driven. So we can estimate cost based on how many tasks we have, and how many resources we have available for those tasks. And then it's just a simple calculation of number of resources, number of tasks, and the overall schedule. But it's kind of a different perspective here in a way. Whereas Parkinson's Law is more, we are saying there is a schedule, but our cost is based on the people available. Here, this is more a set schedule, a set amount of work packages. So we're not necessarily expanding to fill some schedule. We just have kind of already a set amount in a way. So minute difference. Here it's also kind of estimated too. So schedule driven versus Parkinson's Law driven. Resource versus people. The fun part is people are resources too. Okay, now we're going to get into the interesting things, and some of these I'm just going to forewarn you, I'm going to hand wave a little bit because that's what professors do. um, no, mainly because these are going to be a little bit more detailed models. So with cost estimation, it definitely makes sense to bring in algorithms to handle these costs. Um, you can't just kind of eyeball a project and say it's going to cost $500,000. That's all you're ever going to need to pay. Um, there are a lot of metrics that go into cost estimation. There are a lot of fine points, a lot of gray areas, and we basically can model this algorithmically. Um, so what are we going to use? The absolute simplest way is to measure based on the size of the project or the lines of code that we're writing. This is kind of an old school approach. If you have 500,000 lines of code, this is how much it's going to cost you. That is a super naive way to look at it, but that's what some of the older, projects used to be estimated as. It's your cost per line of code type of approach. Not always the best thing because obviously some lines of code are way more important than others, but there is that. So one way that we can look at this is if we have a million line code application, we can look and compare at other similarly sized applications that we've written in the past. They're probably going to cost similar. What's going to be involved? Developers writing that code, the time and effort to test it, debug it, model it, verify it, everything in our software process. It's probably going to be similar-ish. But again, not all code is the same. So algorithmically, we can use a model known as COCOMO. So this is one of your homework questions too, by the way. I'm very happy we got here today. So constructive cost model. So COCOMO 1 was developed in the 80s, and take that into account when we talk about this, that software projects were different then, right? COCOMO 2 was developed more recently, and it was intended to take newer project ideas, newer programming paradigms into account. We're mainly going to cover COCOMO 1 because it's the most approachable, but keep in mind it's not like this is not the end all be all to algorithms. There are a lot of different ones out there, but this is kind of the best known as well. And this model, and again, a model, if you're not familiar in terms of algorithms and predictions, basically we use models to make predictions. And a model is different than a software model. It's different than like a UML model. This is a analytics model where based on a whole bunch of historical data, we feed it into this algorithm, and based on what we're looking for, it spits out a prediction. So, question for you. Now that we know what an empirical model is, if we are making predictions based on history, is there any issue with this for new projects? This is where I want you to kind of think critically about using predictive analytics. And kind of a nice way to maybe think about is this is kind of the basis of all of the machine learning models, all of the pattern recognition models that we have. Similar idea, right? We are making predictions. Algorithms that analyze handwriting to figure out what letters are. Algorithms for automotive, autonomous automotive path detection or um, path selection. We're using an algorithm to make the decision. Doesn't account for new technologies and new practices. Right, so that is one thing. If we have a new paradigm, this model doesn't work. Okay, so one of the things that I will say here, this was developed before object-oriented programming became a thing. Okay, COCOMO 2 takes that into account. COCOMO 1, the older version, we're just purely procedural coding. Lines of code make sense. When you start adding in abstraction layers, right? That's what we get with object-oriented. We have lots of extra lines of code just to make developing easier and more, I guess, kind of intelligently driven depending on the application. That can really balloon a project. You know, if I've got 100,000 lines of code in Java versus 100,000 lines of code in C, most of that code in Java is probably going to all those class declarations, all the getters and setters, and all of the layers of indirection, right? Whereas in C, it's probably just straight up functions, pointers, all the basics there. So yeah, it doesn't account for new things, but what if we feed this model bad data? So let's say we feed it 50 software projects and all the metrics and all of that, and then we try to predict, and it turns out that all of those past predictions were bad. Like they're way over budget or they're way under budget. It's probably going to do something similar with the current version. So I guess kind of the takeaway here is that you have to supplement estimations like this with a real world perspective. So have a domain expert, meaning somebody intimately familiar with this type of project that you're building, maybe with the costs involved, and say, does this prediction make sense? Maybe there is some latent or hidden feature of this new software project that the algorithm just can't account for. And that's where a human element is always, always, always going to be necessary. Is the model going to be good? I mean, yeah, it's probably going to be good. It might not be exact, but it'll be decent. Gives you at least an idea of what you're looking at, I guess. But don't just trust the algorithm. Make sure that you kind of critically think about what comes out of it and what you feed into it. So, but yeah, good point. Doesn't account for the new things. I guess another example too, just to really give you a current example. Quantum computing is the new thing, right? Whether you think it's a buzzword or not, it is probably going to be a programming paradigm that changes everything. Right now, it's in its infancy, and there's probably going to be a period where people forget about it, and then it will come back at some point, and it will go away and it will come back. That's just kind of how programming works, right? At some point, it's going to be a new thing, and old models like this are not going to be able to predict what's involved. Just like object-oriented programming came in the 90s, turned everything on its head. Pretty sure quantum's going to be the next thing that does that for programming. It requires new hardware, it requires new ideas and new ways to program. Um, and if nobody knows what I'm talking about, there are actually Python packages out there right now where you can do quantum computing on your own computers. That's how far along simulating it has come. You can rent computing instances of actual quantum gates. It's actually coming, and this is something that you're all probably going to have to deal with at some point in your careers. And if you do or do not, you know, not trying to make any future predictions here, but I'm pretty sure it's going to happen at some point. So a lot of the stuff you're learning here, there's a good chance it becomes deprecated by the time that comes around. but we'll have new models. We'll have new strategies. Okay, so COCOMO. We have two models, at least at this point. COCOMO 1, published in 1981. This is absolutely in lockstep with the waterfall model. So take that for what if you want to kind of identify it in the timeline of software history. Very procedural, bop, 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 not a lot of uncertainty in the process. Good for that kind of a project. COCOMO 2 comes out in the 2000s. It now can handle a little bit more complexity, a little bit more flexibility. I honestly am not sure. I haven't looked recently to see if this is up to date with the latest software paradigms, like some of the newer Agile features, but I'm going to guess that there are models out there for that. It's just how popular Agile is. Of course, we need an algorithmic model to predict it. But we're going to focus on COCOMO 1 here because this is the basis of all the other models. So what do we care about? Well, we're going to estimate the effort for a project based on how big that project is. And we are going to take in factors like how many lines of code, not including comments, by the way, comments don't count. How many kilo lines of code do you have, or thousands of lines of actual real code? We are also going to consider, because again, lines of code doesn't necessarily tell you anything. I could write a one-liner of code in like 4 or 5 lines and get the same behavior. We're also going to care about function points. So function calls, calls to external libraries, calls to outputting data, user interaction hooks, maybe pulling in files or writing files. Do we have an interface to an external entity? That's going to count too. How many user interface screens are we popping up? How many reports do we have to generate? Excuse me. How many additional components are we building? Basically, we're kind of going through and looking at a project pragmatically and really just trying to see that what are all the kind of important things in this project, right? Lines of code, easy metric, but we're also going to factor in how important those lines of code are as well. And these are kind of the size measurements that we have. So if we have a project size, we're also going to pass in a mode and some cost drivers, which we're going to talk about mode and cost drivers next. These are basically things that you can tweak. And if you're familiar, I guess if you're familiar or not with models, it's an estimation level. Basically, these are like the little configurable points that you can play with to have your model make different predictions. We're going to pass these in as well. And what we get out of this black box is the effort required and a schedule. So this is what our model is doing here. And the black box that you see is basically the magical model under the hood. If you go the machine learning route, if you go like a pattern recognition route, and you're learning about analytics and things like that, the black box is the prediction algorithm. It's the neural network that makes decisions, right? It's the deep learning environment, which is basically just a neural network that makes the prediction. Here, it's just a simple algorithm that factors in these features here and spits out an answer that you're looking for. But this is really any prediction engine ever. Inputs, black box, outputs. So we can pass in a mode. Actually, let me skip ahead a little bit here too, because I want to show you. So there's this Geeks for Geeks link that I've got here that actually talks about the COCOMO model as well. And it gives you, interestingly, the code for writing COCOMO. So if you want to write it in C++, here is the actual model. So here you get the mode is organic, effort is 10 about 3 person months, takes you about 6 actual months of development time, and you need 2 people to work on this. So this is kind of the output that you would get out of a COCOMO 1 model. And we have different ways that, again, we can tweak this as well. I just wanted to show you that, hey, you can actually write this in C++, and that's your model. It's really not all that complex. And I thought for some reason they had, no, they don't have it. I thought there was other languages here too, but really it is not a hard model to develop. You could very easily write this in Python or even an Excel macro. But I recommend checking out this page if what I'm saying really doesn't track all that well. All right, full screen again, please. There it is. So I said that we're going to pass in a mode. Okay, so this is the first thing that we can tweak. So the first one, and basically we have three modes, we can say this is a basic mode. This is simply looking at the program's size. So we don't care about all the extra features that a real world project's going to have. We just want to know if this is going to be 500,000 lines of code, how much will it cost approximately? How many people do we need? How much effort do we need? If you're going this route, this is a very, very basic predictor where you're not using this for real, you know, project planning, but you're trying to get an idea of how it's going to look. All right, so think of yourself, let's say that you are a business manager. You're not a developer, but you work with developers. I'm trying to figure out, okay, let's go back to the automotive route because that's what's in my head today. We're speccing out a new subsystem, okay? I need to build a controller for this car where it's going to take in data from every other component and it's going to make analytical decisions for for autonomous. Sure, we can go that route. Okay, I don't know how to program that, but my team does. I'm expecting, based on what my engineers tell me, this is going to be 3 million lines of code. How many people do I need for this? How much effort do I need? And I can plug into this model, which again, it can be an Excel macro. There's, nothing wrong with that. Here's about how many people I need. I can start planning things out. I can start requisitioning resources for my project. But this will be iterated over time too, right? So this basic, very, very easy, very, very early in the project. One other thing to mention too, there's really only one input here. Okay, calculating out these inputs does take some time and planning on your part if you are using a model. If you go the intermediate route, this is going to take that program size, so how many lines of code, plus some cost drivers. And these are subjective assessments, meaning it's not always purely analytical. It can be how we feel based on like what we think is needed, right? It's personal thoughts, personal kind of predictions. Now, when would you do intermediate? Probably after your requirements are laid down and crystallized. So you know a lot more, right? If we look at that project timeline, regardless of your development method, waterfall, agile, doesn't matter. The further you get along in the project, the more information you have, right? And that goes back to our brief diversion into information and uncertainty theory and that kind of stuff, where the more information you have, the better estimates you can make, right? So we're refining our estimates as new information comes to light. To quote, God, I swear when I teach, I feel like I'm 90 years old and I have no short-term memory anymore. Oh my God, really? You can see the picture. I feel really, really bad for not remembering this now. The Big Lebowski. Oh my God, best movie in the world. I can't remember the title. Swear, short-term memory is leaving me. As new information has come to light. That's the joke. But what do we care about? Assessments of the product, assessments of what the personnel we have and are going to need are. Maybe what the customer wants, maybe some other project attributes that have now kind of surfaced. So basically, you're providing the model with more detail as you get those details. And then you go the advanced route. This is after your design, meaning after your modeling, after your design decisions are made, kind of requirements, design, then you would go into implementation, right? So this is kind of in between design and implementation. So we have the program size, plus we have more cost drivers, so even more, plus maybe they're weighted with how important they are. Okay, so these are kind of nebulous ideas right now, right? Cost drivers, we don't know what they are, but we know that we have a very rough estimate, we have a better estimate, and an even better estimate, and these are applied at different phases of design. So we have this one. We also have development modes. So basic, intermediate, advanced, based on timing of the project, based on information that you have. You can also specify this model to run as organic, semi-detached, or embedded. So if you're running it in an organic mode, this works best when the project is small, when your teams are flexible, when your requirements are not strictly set in stone. So think of an organic project team, right? Like almost an agile type of team. This is where you'd specify organic. But the project itself doesn't have a lot of moving pieces, right? We can pretty easily estimate based on what you see. Now, if you specify to run in semi-detached mode, you're going to have a more complicated project, right? You're going to have still maybe not super rigid requirements, but you're going to have some uncertainty maybe in your teams. So you can kind of see with these models, and this is not specific to COCOMO, this can be any of them. You would configure this prediction engine, this, whatever model we're using, based on the cost of the project, based on team makeup, based on requirement setup, and you're going to take all of these kind of subjective terms and try to crystallize them into some metric that you can act on. All right. So we have that mode, and then we have embedded mode where we have very rigorous constraints. Hardware and software are safety critical. Basically, we can't make a bad decision here. It's important that we don't, kind of give this short shrift here. So different modes that we can specify in the development side of things. And again, these are configurable tweaks that you would pass into the model. Is it organic? Is it embedded? Is it basic or advanced? So now we are at the point where we actually talk about the model. And let's see, we're probably not going to get too deep into the cost drivers today. That'll be next time. But the general formula is going to be the effort is some constants, C and K, and these are basically provided by the model. We'll have a lookup table to fill in these blanks. C times size to the power K times M. M is based on some of those cost drivers. So we're, again, filling in metrics here. They're going to look like magic numbers, but basically they're kind of empirically derived, meaning we have past evidence that these numbers work well for this type of model. And what we get out of it is a person month. So 1 person month is the amount of work / effort by 1 person in 1 month. So that is the formal definition of a person month. If I give you all term projects and we have 2 months to work on it, that is, and I say you have 5 person months worth of effort, it's going to take, 5 people, 5 months worth of effort each. That's kind of how that would boil down. It's a slightly different measure, but kind of think of it as a working week based of things. So it's not you're working 24 hours a day. It is you're working 40 hours per week kind of a thing. And again, highly recommend checking out the link because it will go into the actual algorithm. So this is our effort model. That's our person months. Now, based on if we are going basic, intermediate, or advanced, we don't have the advanced one here. If you're picking the different development mode, you're going to have a different calculation here. So the figure is still the same, or sorry, the equation is still the same, but based on which mode we are in, we're going to fill it in with different values. And those different values, we're basically going to list out as a lookup table. Okay, so you're going to see these values kind of come back. So if we're going organic, we're going to fill in these slots at 2.4. times the kilo lines of code to the power 1.05. And based on that, here's how many person months you have for a project. So if you have 1,000, sorry, if you have 1 kiloline of code, that's 1 to the power 1.05 times 2.4, that is your effort. If you have a lot of kilolines of code, that's going to factor in too. You go intermediate, we're going to have very similar, features here, but we're also going to add in these cost drivers, which you have to figure out as the project manager or as the business manager. And then when we go advanced, we're going to have even extra, stuff to filter in here. But a very simplistic model that we get here. And again, the algorithm is not all that hard to develop. What we're going to leave off with here is the cost drivers. So for COCOMO 1, we actually have 15 different cost drivers that we can add. And this is going to go into the calculation for this one value of M. Right, so this is our M right here. Sorry, this should be intermediate / advanced because I'm pretty sure this is the same algorithm. It's just how much goes into M. But what do we care about? Care about product metrics, care about computer metrics, personnel metrics, project metrics. And then we're going to rank them. This is where that subjective nature comes into play. How important is personnel? How important are project specifics? This will go into that M calculation. So yeah, what we're going to leave off, I think we'll probably end here because this is a deeper discussion that hopefully we can go over Friday, but again, we'll see. So this is the basics of COCOMO. Any questions so far? Again, just to kind of summarize here, the nice thing about this model is that you can get a fairly decent estimate for project effort. May not be perfect, but it's a good start, and it's something that you can refine. And when we talk about refining this model, let's again look at the project planning aspects that we're talking about here. You are a business manager or a project manager. Before you even start development, you look at the estimated amount of effort. I'm going to need 10 people to build this. Okay, so then we refine our model in 2 months. Well, crap, it turns out we only needed 8 people. What do you do with those other 2? Well, you can release them to work on other projects. You can reallocate them to other aspects of the project. You can basically get an exact feel for what resources you need. And again, resources can be people. They can be devices. They can be project support, just whatever your project is going to need. But a model like this will help you estimate cost and estimate effort. So that is all I've got for you today. Good luck with getting up and running on the homework. And again, if you joined late, the very ends of these slides, I've got links for how to do Gantt charts, how to do burn up and burn down. Make sure you check that out. Anyway, I'll see you next time. Have a wonderful Wednesday. Let's get some Breath of the Wild lo-fi to sign us off here, and have a great day. See you, everybody.